My screen is visible? Okay. And what do you see on the screen? Sarvesh, what do you see on the screen? Atharva? Yeah, an animation. So you can see how the two sprockets are rotating and a duplex chain is rotating over that. So what is chordal action? We were discussing the other day. What do you mean by chordal action? Ambika? What do you mean by chordal action? Pranav? Ambika, Pranav, who is answering? Manish? Are you there? Manish? What is chordal action? Lokesh?
Ma'am, the chains are wrapping around the sprocket.
That is chordal action. Okay, so that was a duplex chain and this is a triplex chain which we were discussing in the other day. So if this is a sprocket and these are the links of the chain, if there are only 4 teeth on the sprocket, then this chain would move like this and this is like a cord. And it is, since the links are moving like the cord, the motion is not very smooth. And this non-uniform motion leading to a lot of noise and vibration, this is known as the chordal action of chain. So chordal action is basically the action of the chain, which is because of the length of the chain, finite length of the chain, which are perfectly straight. Since these links, they are perfectly straight, they are making the chord of the circle. And before this moves from here to here, or this moves from here to here, it has to lift up and there is an angle of articulation. So the same figure, if I try to draw again, this is the initial position. This would be the final position. This is known as the angle of articulation. We want ideally this angle of articulation to be as small as possible, for which the distance between the two pins, this is known as pitch. This pitch should be small, and for the pitch to be small, the number of teeth on the sprocket should be large. So let's see what happens if the number of teeth on the sprocket is small. Suppose there are only 4 teeth, like this. So look how the sprocket and the chain, they are moving. So while this is moving, for this particular position of the pin of the chain, here this diameter is d/2, which is half of the diameter of the sprocket. And for this particular position of the chain, here the location of the pin is d/2 cos α/2 if I take this angle as α/2, which means the value of omega is same because the sprocket is rotating on the shaft. This is constant, but the value of distance, that is the diameter, this is continuously varying, and this is varying again because of the chordal action of the tooth. And since diameter is continuously varying, the value of peripheral velocity, this keeps on varying. So this increases when the diameter increases like this, from a maximum value of velocity to a minimum value of velocity, depending upon the location of the chain. Since this is forming a polygon, when this reaches from here to here and here to here, its diameter or the distance of this pin from the center is continuously changing. And so there is a continuous variation in the peripheral velocity or the linear velocity. Experiments have shown that as you go on increasing the number of teeth, now here the number of teeth are how many? 1, 2, 3, 4, 5, 6. So from 4, if I increase it to 6, now this length of the cord, this has reduced, but still there is a variation in the peripheral velocity. For this particular position of the sprocket, this is the distance of the pin from the center. For this position of the sprocket, look at the position of the sprocket. This is the distance from the center. So this distance small r is definitely less than the distance capital R, which means the maximum velocity here is omega into capital R. The maximum velocity here is omega into small r. So here again the velocity is, the peripheral velocity is changing from omega into maximum distance to omega into minimum distance, small r and capital R. So if there are 10 number of teeth, this change in the peripheral velocity because of the chordal action, the percentage variation of speed from the mean speed is plus minus 5%. So if ideally the peripheral speed is 100 meter per second, this keeps changing from 95 to 105. So this would be the variation. If we increase the number of teeth on the sprocket to 17 teeth, then the mean speed variation is plus minus 1.7%. And if it is 30 teeth, this is from experimentation, we'll see this variation is plus minus 0.5%. So for the smooth operation, what do we want? We want that this variation should be as small as possible, which means the number of teeth should be high. So as the number of teeth go on increasing, what will happen to the cord length? Manish? What happens to the cord length? It will decrease. So more the number of teeth, the cord length would decrease, and then this polygon will almost become what? The polygon becomes circle. And with circle, this would be as smooth as a gear or a belt drive. But what happens with increase in the number of teeth is this pitch. Pitch is a distance between any two pins of a single chain. The value of pitch, this decreases because you have to increase the number of teeth. So they will be placed very close. So either the pitch reduces to increase the number of teeth, or you will have to increase the diameter of the sprocket. Increase the diameter of the sprocket if you want to increase the number of teeth. What will happen if you increase the diameter? peripheral velocity will increase. But peripheral velocity cannot be increased to a very high value because this leads to increase in the centrifugal force. And this is again undesirable. We don't want the value of Fc to increase. And hence you have to always compromise with what should be the pitch, what should be the number of teeth, so that this variation is less. So if we want to have lesser pitch, higher number of teeth, power transmission to be more effective, then we go with this duplex chain or with this triplex chain. This is a duplex chain and this is the triplex chain. So the power transmission capacity becomes double or becomes more than 2 times. It is not exactly double. If for a single strand it is 1, for a duplex chain it will become 1.7 times of the power transmission capacity of the single chain. For triplex it is 2.5 times that of a single chain. So we are increasing it by increasing the number of chains. So that is the advantage of using a duplex chain or a triplex chain. We have to find out the correlation between the diameter of the sprocket and the pitch. An exaggerated view for a sprocket where this is the pitch. This to this distance is the pitch distance. Which is measured along the straight line for the link. This to this is the pitch. We are measuring it along the straight line. If the angle between this, if I am considering as say 2 times of alpha, r is the radius of the sprocket, and if this angle is 2 alpha, if number of teeth on the sprocket is t, then 2 alpha, which is the angle between any 2 pitch points, or the 2 alpha is the angle between 2 teeth. What will be 2 alpha in terms of number of teeth? What will be 2 alpha in terms of number of teeth? If total number of teeth is t, yes, it is 360 by t. Or alpha, as it is given, half of this angle is 180 by t, where t is the number of teeth. And this radius of the sprocket, or if we write down the diameter of the sprocket, the pitch circle diameter of the sprocket, by 2. If this angle is 2 alpha, the half angle is alpha. What is r sine alpha? What is r sine alpha? This we are measuring in straight line. This to this is a pitch distance. What is r sine alpha? This is half of the pitch. We'll use small p for pitch because capital P we are using it for power. And from the expression of this alpha and sine alpha, I'm rewriting this as the diameter for the sprocket. I'm using dsp. This is equal to p upon sine of alpha, or this is pitch p upon sine of 180 by t. This is the relation between the diameter of the sprocket, number of teeth on the sprocket, and pitch p for the chain. Now the length of the chain is calculated similar to the length of the belt, and so the same formula is used, which depends upon the diameters of the 2 sprockets and the center distance. So what is the formula for length of the belt? 2 times the center distance plus pi of diameters of the 2 sprocket by 2 plus d2 minus d1 whole square by 4c, right? Now here, in case of chain drive, we always specify the length in terms of pitches. We don't specify the length of the chain in millimeters because chains are the integral links. So it has to be either 30 pitches long, 45 pitches long, 70 pitches long. So we always express in terms of pitch. So now when you want to write down length in terms of pitch, length upon pitch, this is the total length of the belt is say 100 mm and the pitch is say 5 mm. What is the length of the pitch? This will be 100 by 5, that is 20. So we specify this as LP. LP is the length of the pitch, which is length of the chain in millimeters upon pitch in millimeters. So we are dividing this entire expression by pitch to get this formula. So I'm writing this as 2c by p plus, everything gets divided here, pi d1 by 2p plus pi d2 by 2p plus d2 minus d1 whole square by 4cp. Like L by P we are mentioning as LP, which is the length in terms of pitches. Similarly, C by P is center distance in millimeter upon pitch in millimeter, and we are calling this as center in terms of pitches. So center distance will never assume as d1 plus d2, we will assume as 30p, 40p or 50p. So the range of center distance in the design data book is 30 to 50p. We'll by default go with 40p and then we'll recalculate whether this is correct. So rewriting the expression, LP is equal to 2 times CP. CP is center distance measured in terms of pitches. What is pi d by P? Saurabh? What is pi d by P?
Circumference measured in terms of P.
No. For a gear? What is pi d by P? This is number of teeth. This is T1 by 2 plus T2 by 2. This is the count of number of teeth. Plus, here I am rearranging this for simplification. I am writing multiplying and dividing this with p square pi square, so that inside the bracket I can insert pi d2 by p minus pi d1 by p whole square divided by 4 times C into P. And so this comes out to be 2 times Cp plus number of teeth on the 2 sprockets, its average, plus this P square and this P, this gets cancelled, leaving 1 P over here. Pi d by P, this is again number of teeth on the larger sprocket. This is number of teeth on the smaller sprocket upon 4c into pi square. What is the value of pi? Value of pi, Anish? Anish? Pi is 3.14. So approximately square of pi would be 9 point something, right? Say 9.5. This is assumed to be 10 multiplied with 4. So this comes out to be 40. So this is 40 times C. So we are assuming pi square as, this will come out to be 9 point something something, assuming it to be 10. So this is 4 pi square, this is taken as 40 C. So this is the length of the chain in terms of pitches. So, okay, one more term, power transmission capacity, and then we'll start solving the problem. So again, for a sprocket, you will have a tight side tension, you will have a slack side tension, and the strength of the chain should always be greater than the tension on the tight side plus the centrifugal tension plus the tension due to the chordal action. So chordal action is variation in the peripheral velocity due to the finite length of the links, because they are straight lines. So either this is used as T1, T2, T3, or it is used as F1, FC and FCH. This is to avoid T for torque, T for number of teeth. So we are using this as F1, FC, FCH. We are using T so many times, and this, yes, it leads to confusion. So this braking strength, this is the braking strength which is given for the link in the design data book. So this is the braking load or the braking strength. And as I said, this value is pretty high because the factor of safety that is assumed is almost 10. And since the factor of safety is very high, this will never reach this. So the failure criteria is increase in the length of the pin, increase in the length of the chain because of wear in the pin. And so the criteria for failure is the projected area of the pin. So if this is the pin, if I take a section of pin, this is its bearing area. So this bearing area into the allowable bearing pressure, this becomes the strength of the pin or the bearing surface. And this area is length of the pin L by diameter of the pin. Length of the pin, let me use it small l, into diameter of the pin. And so finally the effective power transmission capacity, this depends only upon the tension in the belt, T1. It doesn't depend upon the strength of the belt. So finally what we get is, this is this T1 into Vp, or if you allow me to write down F1 into Vp. By formula, this comes out to be the strength or the braking strength minus the centrifugal minus the chordal load multiplied by Vp. Now everything is in terms of pitch and velocity, and this is quite a complicated expression. You can refer design data book Shivalkar for the formula for pressure, for the power capacity of a roller chain, and exact equation is given. Refer page number 150, table 14.1. Table 14.1. And then there are tentative graphs for selection of the pitch and the number of teeth. And those graphs are also given. There are only 2 graphs given here in the BD Shivalkar design data book. I'll be sharing you more graphs, and we'll be solving the problem again from Shivalkar data book and PSG design data book. So for now, let us refer BD Shivalkar. So what is the formula for PR given over there? Somebody can just read out. Manish. Harshini, can you read out the formula? Design data book, BD Shivalkar, table 15.1. From my book, this is page number 150. Whose mic is working? Sarthak?
Yes, ma'am.
Yeah. Could you refer to that page on the Shivalkar design data book?
Yes, ma'am.
Yeah. What is the value of P given? Formula for P?
PD, it is given PR into K1.
No, the exact equation for power capacity of roller chain. On the same page, same table.
Yes, ma'am. This exact equation is P square
Hmm.
in the bracket V upon 104
Hmm.
minus V to the power 1.41
Hmm.
by 526.
Hmm.
Another bracket
Hmm.
26 minus 25 cos 180 by T.
Hmm.
Bracket close
Hmm.
and whole bracket multiply by Kc.
Kc, where Kc takes into account a number of strands. So for a single strand, this value is 1. For double strand, the power becomes 1.7 times. For triple strand, it becomes 2.5 times, and likewise. You can also see the formula for length of chain in pitches, then the relationship between the pitch diameter and the number of teeth which we have derived just now, and then the recommended wear load. So with this much data, let's start solving a problem. Please take the problem statement. 1000 RPM motor, 1000 RPM motor is used to transmit 7.5 horsepower to a compressor shaft. Power is given in horsepower, and the design data book is also giving you power in HP. So we'll keep it as it is for now. Later we'll change it to kilowatt. So I repeat, 1000 RPM motor is used to transmit 7.5 horsepower to a compressor shaft which is running at 350 RPM. The compressor is used for 12 hours per day. Suggest a suitable chain, number of teeth on the sprocket, length of the chain, the actual center distance, and the type of lubrication. So we have to design this chain, or rather we have to select the chain. So there is a tentative selection from the graph that is given in the design data book. And then we'll check whether this is correct, or we can slightly modify. So the graphs are used for tentatively selecting to start from somewhere. So the rated power is 7.5 HP. What would be the design power? What is the service factor that you would take? Motor driving a compressor, assuming this to be a moderate shock. The same table is giving you for 12 hours, for 10 hours per day and for 24 hours per day. This is mentioning 12 hours per day. Same page, table number 14.2. So for a moderate shock and for 12 hours close to 10 hours, say we take, what is the value of K? 1.2. So give me PD. Give me the value of PD. 9 HP. Abhi, this is running at 1000 RPM 9 HP single strand. Refer next page, figure 14.1, page 152. Next page. Can you see number of graphs? Those graphs are indicating the type of chain. Now, type of chain is indicated as hash 25, hash 35, hash 40, hash 50, hash 60. So the meaning is hash 25 means 1/4 of an inch. This is the pitch, 1/4 of an inch, which is 6.25 mm. Hash 25 means 3/8 of a pitch, hash 40 means half inch pitch likewise. So for 1000 RPM, 9 HP motor, we are designing for PDS 9 HP. Can you give me kitna easy hai on the mobile screen checking this out? What is the type of chain number? For single strand. Yes. Manan, which chain should we select? I am not receiving the messages on chat box. Karthik? Which chain for single strand? When I say chain, yeah, that is hash 50. What is the pitch? How many number of teeth? For chain number 50, what is the pitch given? Number of teeth, 21. Pitch is 15.8. 875 mm. Now the first check here is the kind of pitch that you are selecting. We have to check what is the diameter of the bore. Bore is, we are selecting the sprocket, and the sprocket will be mounted on the shaft. So the bore is the hole which is cut in the sprocket for this shaft. Check what is the diameter. For pitch less than 25.4, in the previous page or in the table 43, it says that the maximum permissible diameter of the bore would be less than number of teeth minus 5 into pitch by 4. If the pitch length is less than 25. So what is the maximum permissible diameter for the bore? Give me the answers quickly, please. It is 63.5. This is the bore diameter, so our sprockets should be sufficiently larger than this. How do you get the sprocket diameter? Pitch upon sine of 180 by T. T is 21, pitch is 15.875. Check what is the sprocket diameter. This is the sprocket diameter. 106. So this is sufficiently large. We can go ahead with this. Got it? Suppose this is 63 and this comes out to be 65, or this is 63 and this comes out to be 60. Then we'll have to increase this pitch. So instead of hash 50, we go with the next hash 60. Or we change it from single strand to double strand. So we'll solve that kind of problem where we'll have to change the number of strands here. Okay, so knowing this diameter, knowing the RPM, let's find out what is the peripheral velocity first. Pi into this diameter into N1, it is rotating at 1000 RPM motor. What is the peripheral velocity? And if T1 is 21, what is T2? Is that 5.57? Yes. Number of teeth inversely proportional to the ratio of RPM. So what is the number of teeth on the larger sprocket? 21 into 1000 by 350. Coming out to be 60. Okay. Now you know pitch and you know velocity and number of teeth. Give me what is the power capacity of this roller chain. What is the power transmission capacity of this roller chain using the same formula? P square into this entire bracket to Kc. For a single strand, value of Kc is 1. This will take some time for you to calculate. T is 21, V is 5.57 meter per second. Pitch, you have to take in millimeters. Velocity, you are taking in meter per second. So the dimensions and the units, they are balanced with those numbers 104 and 526. And you will get the power in kilowatt. I repeat, pitch in millimeter, number of teeth is what you have taken, velocity in meter per second, and you will get power in kilowatt. So this should come out to be around 9, ideally greater than 9. But it has to be definitely greater than 7.5 HP. Give me power P. Is that coming 7.9? You are giving me in kilowatts, Ayush? You are giving me this value in kilowatt, right? Can you quickly convert this into HP? 1 kilowatt is almost 1.36 HP. This is how much horsepower? .6, 10.7. Yes. So what is the required design power? That is 9 HP. And the chain that we have selected, 8.97. Why you are getting different answers? Kaustubh and Saurabh, 8.9 and 10.6. Saurabh, what is your value of power in kilowatt? Kc is 1, T is 21, V is 5.57, pitch is 15.875. How many of you are getting 6.6 kilowatt? Most of you. Even my value is 6.6, not this. 6.6 kilowatt, which comes out to be 8.9 horsepower. This is just close to 9 horsepower. This should ideally be little greater than 9 horsepower, but for 8.9 we can go with this. Otherwise you will have to increase the pitch. Increasing the pitch means you have to go for the higher chain, that is hash 60. If you go for hash 60, then the pitch increases from 15.8 to 18.75, and with this much increase in the pitch, this power will increase from 9 to maybe 13, 14 or 15 times. 15 HP. So which will be too strong, and this is just enough. Although not very safe, but this is just enough. And we will also check this for the bearing pressure before selecting the next pitch. Okay, so this 6.6 is correct, which is almost 9 HP, little less than 9 HP. Give me what is the length of the chain in terms of links or pitches. So you have to initially assume some center distance, which as I said is in a range of 30p to 50p. By default, let us take it 40p and later we'll modify this. So if Cp is 40 times pitch, which is 40 into 15.875, T1 is 21, T2 is 60, give me the value of Lp. This is the length of the chain in terms of pitches, or this is in terms of number of links. This is 40 into 15.875, which is how much in millimeters? .635 mm is what we are assuming. Give me the length of the pitch, length of the chain in terms of pitch. Ajinkya, Daitwa, give me the answer for length of chain. Dhruv, are you there? Dhruv, 54. Logged in through mobile and roaming around. Daitwa, you are there?
Yes, ma'am. Solving.
Okay. Okay. Kaustubh? Kaustubh? Nandana and Saurabh are giving me 158 and 135. Is this the value for LP? 2CP plus T1 plus T2 by 2. We are using this formula. CP is 635. Why your answers are varying? 1311.5. Um, 1313. Getting such kind of answers. 1310. 135, 158. T1, T2 are 21 and 60, right? Are you giving me the length in millimeters? What is the value for this? 21, 60. My answer is 121.45. These many number of links. Rajul is getting 121. My others are getting 1311. अभी सबके 121 आ गए. Why others are getting 1311? Riddhima, Nandana. Please check your answers.
Ma'am,
Yes.
ma'am, in the third term, it's P into T2 minus T1 whole square.
If you are using this as P, then this is C. And if this P goes here, then this is C by P. C by P is this CP. CP is this C by P. How you are getting 121, Prathamesh? Prathamesh?
Hmm, Same, I took this
CP
T260,
is 40.
T260, T121, and CP 635, right?
Yes.
So yeah, it came out to be, I mean, 121.82.
So you are directly using CP, which is C by P, as 40 here.
Hmm, 40 into CP, right? So 1 second, I'll check this one.
No, Nandana, you are getting 121.
Yes, ma'am,
Ma'am,
40 into 635.
we got confused with C and CP. We took C as CP.
Yes. So this will be, if this is Cp, this is C upon P. So this P goes here and this becomes C by P, which is 40. Similarly, this Cp is 40. This is C by P. So if you are getting 121.45, number of links will always be an integer number, an even number. So we use 122 links, which means since we have increased the links from 121.45 to 122, now we have to recalculate the value of Cp. We have to recalculate what is Cp, and if number of links is 122, give me what is Cp now. So this will be exact center distance. पहले तो हमने ये assume किया था, right? This plus this. And now when you recalculate, you will get Cp as little increase, so it will be 40 point something. Give me what is that something. क्वाड्रेटिक इक्वेशन आ रहा है नहीं no t1 and t2 are known, it will not be a quadratic equation. It's a Cp square. करो solve a quadratic equation. So you can continue. So this comes out to be for 121.45 converted to 122. So for 122 link, as the length of the chain, the Cp value comes out to be 40.27 as per my calculation. And so the actual center distance taken in millimeters is 40.27 into the pitch, which is around 639.3 mm, as against 635, which was assumed with 40p, came out to be 635. Yeah, so with 40.278, go with more precision, you will get this as the actual center distance. So this is how we select a chain. Instead of designing a chain, we select a chain. So a quick recap for the RPMs given for the input and the output shaft and the power to be transmitted given using B.D. Shivalkar design data book, we find out what is the design power. And for this design power, we select a chain from the graphs. This is the tentative selection. We find the pitch. We check for this pitch and number of teeth, what is the bore diameter. And we check that the sprocket diameter is definitely greater than this bore diameter. And if this is true, then we can proceed. We find out the peripheral velocity. From the peripheral velocity and the pitch, we have to find out what is the power transmission capacity, which should ideally come out to be greater than PD or at least equal to PD. Else we'll have to increase the chain that we have selected, increase the pitch of the chain, and then we find out the length of the chain in terms of pitches or links, where Cp is assumed as 40. So 40 is 40 times the pitch, and we find out what is the number of links in the chain. Now this cannot be a decimal number, it has to be an integral number. And for this integral number, we recalculate the exact center distance. Next class, we'll talk about checking the bearing pressure, and we'll solve the same problem from PhD design data book, and there the approach is entirely different. Okay, you are free to ask questions now. If anybody has any questions, whatever we discussed today. Yes?
Ma'am, why we have taken CPS?
Sorry, I didn't hear you.
Ma'am, why we have taken CPS 40? Can you explain about it?
Okay. Refer design data book. It is giving you the center distance formula. The center distance should be greater than half of the outer diameter of the sprocket, or it says that it has to be in a range of 30 pitch to 50 pitch. Can you see that? Table 14.3. So you are free to take some value between 30p to 50p. You could have even taken 30p, calculate the link length, and again recalculate the center distance. So to make it more uniform for the entire class, I am giving you a middle value of this range. Try always to avoid the lower and the extreme or the upper limit. We'll try to stick to some value in between. So instead of 30 and 40, 50, we go with 40p. Okay?
Ma'am, CP is 40p, right?
CP is 40. CP means C upon P, center distance in terms of pitches. So if center distance is 600, if pitch is 60, then center distance in terms of pitch is 600 by 10. That is 60. Length of the chain is length in millimeters upon pitch in millimeter. So that becomes an integral number. That is what I tried to explain you here. Length of pitch LP is L by P. Center in terms of pitch is C by P. So this C by P we are writing as CP. So this would be a number 30, 40, 45 likewise. L by P would be a number, an integral number. This will not come out to be a decimal. So here this CP is 40. Similarly this P upon C. So this here you have to write down as CP, which you take as 30, 40, 50. Or you take it 635 and again take pitch. So you again divide it to get 40. Is that okay?
Yes, ma'am, got it. Thank you.
Okay. Thank you. We continue again in the next class. Unless you ask me doubts, I would never know what kind of difficulties you are facing. Thank you.